Welcome to a study of Leonardo da Vinci, the universal master. To Leonardo, the worlds of art, anatomy, and engineering were never separate silos of thought. Instead, they acted as deeply interconnected expressions of a single, empirical philosophy. Whether capturing the subtle mystery of a human gaze or drafting the complex mechanics of a gear system, his work was driven by a unified quest to understand the natural world. Through his eyes, we see that observation and creativity are one and the same. Explore the formative years of a genius whose mind was freed from scholasticism. Born in Vinci in 1452, Leonardo's illegitimate status barred him from traditional Latin universities, ironically granting him the advantage of learning directly from the natural world. By 1467, he entered Verrocchio's multidisciplinary bottega in Florence, where art merged with chemistry and mechanics. The true turning point arrived between 1472 and 1475. While collaborating on the baptism of Christ, Leonardo's lifelike mastery of oil paint reportedly so surpassed his teacher that Verrocchio resolved never to paint again. This journey from an outsider in Tuscany to a master in Florence illustrates the rise of a man who looked beyond books to see the world as it truly was. Welcome to The Science of Sight, where we witness the evolution of Renaissance art. Before Leonardo, traditional methods relied on fast-drying tempera and stiff linear perspectives, often resulting in hard, unnatural outlines. Leonardo revolutionized this through two profound innovations, sfumato and chiaroscuro. By applying multiple translucent oil glazes, he created sfumato, a smoky effect that mimicked the soft, hazy boundaries the human eye actually perceives in nature. Simultaneously, his use of chiaroscuro employed bold contrasts between light and shadow to grant two-dimensional figures a dramatic sense of three-dimensional volume. Through these techniques, Leonardo bridged the gap between the painted image and the reality of human vision. In his quest for realism, Leonardo moved beyond simple observation to master the very geometry of space and the physics of air. Through linear perspective, he utilized precise architectural geometry to guide the viewer's eye toward a central vanishing point, creating a convincing illusion of a three-dimensional room on a flat surface. Yet, Leonardo also realized that air is not perfectly transparent. His pioneering atmospheric perspective mimics how the atmosphere's density softens edges and shifts distant colors toward a cool, hazy blue-gray. By combining the rigid logic of mathematics with the subtle behavior of light and air, Leonardo learned to trick the eye into perceiving immense, lifelike distance. Follow the expanding map of a polymath, as Leonardo's genius traverses Europe. His journey of expansion began in Milan, 1482 to 1499, where he served Ludovico Sforza as both an engineer and painter, creating the Last Supper while designing formidable war machines. By 1513, he moved to Rome, establishing himself as an empirical anatomist through extensive botanical and anatomical research at the Vatican, until papal bans on dissection limited his work. His final chapter, The Synthesis, unfolded in Amboise, France, 1516 to 1519. Honored by Francis I as the premier painter, engineer, and architect of the king, Leonardo spent his last years unifying his lifetime of diverse discoveries into one final, brilliant legacy. Step beyond the canvas to discover nature's perfect machine. While many believe Leonardo dissected corpses merely to improve the musculature of his paintings, the reality was a 20-year obsession that delved into pure physiology and physics. Leonardo came to view the human body as the ultimate, perfectly constructed machine. Through the dissection of approximately 30 corpses, he pioneered revolutionary illustrative techniques, such as the exploded view, to meticulously map internal structures. His work evolved from surface-level aesthetics into a profound empirical study of life itself, proving that for Leonardo, the secrets of engineering and anatomy were one and the same. Step into the laboratory of a pioneer to witness groundbreaking medical firsts. In cardiology, Leonardo debunked centuries of dogma by discovering the heart's four chambers and used glass and grass seeds to model the aortic valve. His innovations extended to neurology, where he utilized molten wax to create the first physical casts of the brain's cerebral ventricles, mapping their true three-dimensional form. Finally, through a meticulous autopsy of a centenarian, he provided the world's first medical descriptions of coronary arteriosclerosis and liver cirrhosis. By applying an engineer's precision to the human body, Leonardo laid the foundations for modern pathology and changed our understanding of life itself. To Leonardo, the human body and a well-built machine were identical in principle, differing only by the presence of a soul. In this matrix of the human machine, we see physics applied directly to physiology. Leonardo mapped skeletal joints to the mechanical advantage of fulcrums and levers, and used engineering terminology to describe how muscles and tendons generate physical traction, much like cables and pulleys. Even the brain and nervous system were stripped of mystical humors, viewed instead as an active mechanical motor driving the body. By bridging biology and mechanics, Leonardo revealed the body not just as a vessel, but as a masterpiece of functional engineering. Leonardo's brilliance extended far beyond the canvas, manifesting in his roles as a military and civil engineer. For Ludovico Sforza, he envisioned formidable war machines, including finned mortar shells, giant crossbows, and 33-barreled organs, early precursors to the machine gun. His iconographic maps provided generals with unprecedented aerial perspectives. Beyond the battlefield, his civil ambition led to designs for scuba gear, revolving bridges, and intricate canal systems to connect major rivers. Even his monumental art served the state. The bronze for his massive 24-foot Sforza horse was ultimately diverted to forge cannons, leaving his completed clay model to be destroyed by invading troops. Leonardo's work truly balanced destructive power with constructive ingenuity. Leonardo's obsession with flight was his greatest quest for freedom, producing over 500 sketches and 35,000 words. His journey evolved through three critical phases. First, he explored biomimicry, designing ornithopters that mimicked flapping wings, though he eventually realized human muscle lacked the necessary power. In Phase 2, his focus shifted to fluid dynamics, as he began to treat air as a physical fluid and studied the balance between gravity and lift. Finally, his legacy survives in pioneering concepts like the aerial screw and glider. While limited by the heavy materials of the Renaissance, Leonardo's visionary work laid the fundamental conceptual groundwork for the science of modern aerodynamics. We now explore the written legacy, the codices, an intimate look into Leonardo's mind through over 4,000 surviving pages. To prevent smudging his ink, the left-handed master wrote in a unique right-to-left mirror script. Among his greatest works is the Codex Atlanticus, a massive collection of 1,119 leaves detailing weaponry, math, and flight. We also find the Codex Leicester, famously documenting the properties of water and celestial luminosity, and the Forster Codices, which cover hydraulic engineering and his rejection of perpetual motion. Spread today from Milan to London, these volumes serve as a testament to a lifetime spent documenting the mechanics of the universe. We conclude with the ultimate synthesis. In 1516, King Francis I invited the aging Leonardo to the manor house at Clos-Luz, valuing his profound mind above all else. Surrounded by masterpieces like the Mona Lisa, Leonardo spent his final years weaving together a lifetime of empirical research in anatomy, botany, and hydraulics. He famously observed that a full life leads to a quiet death, passing away in 1519 after proving that true achievement lies at the intersection of artistic imagination and relentless scientific observation. His legacy remains a testament to the unified power of the human spirit to both dream and discover.